So, good morning. In the previous lecture, we have seen the graphical presentation of SHM. And in that graphical representation, we have seen three different graphs: displacement versus time, velocity versus time, as well as acceleration versus time. Again, in that, we have seen two different cases. One is when particle will start from mean position. What will be the three graphs? Then particle will start from extreme position. Then what will be that three graphs? So we have written first equation. Then we have formulated the table. Then we have plotted the graph. And from graph we have drawn the certain conclusion. Right? Now, in the today's lecture, we are going to see the next topic. That is composition of two SHM having same period and traveling along the same path. Now, the first word is composition. Composition means combination of what? Of two SHM. SHM is what? Simple harmonic motion. So now, I am going to consider two SHM equations. How that two SHM equation having same period means time interval, capital T will remain same, and they will be traveling along the same path. Same path. Here I am going to consider both the SHMs are traveling along the x. So I am going to write two equations of SHM having same period. They are traveling along the same path, and then I am going to do the composition of that two SHM. Right? Now here I am going to consider two SHM having same period. They are traveling along the same path. Then what will be the different things? They have different amplitude and different initial phase angle. So now I am going to consider that two SHM have different amplitudes and initial phase angle. So initial phase angle, that is your path. So same things are period and they are traveling along the same path. And different things are what? Amplitude and initial phase angle. So now, initially what I write? Displacement equation. X is equal to A sine omega t plus phi. This is the initial equation of the displacement. Now what and what? That here are two SHM. So I write first SHM is traveling along x-axis, its displacement is x1, amplitude is a1, omega is nothing but your 2 pi t, period remains same, and initial phase angle is different, so phi. So in this equation what I have kept? Traveling along x-axis, having same period, amplitude a1, initial phase phi. Similarly, I will write for x2. Second SHM. It is also traveling along same path, that is along x-axis, having different amplitude, at, sine, in bracket, omega t, means period will remain same, plus initial phase angle is phi. So these are your two SHM, having same period, they are traveling along same path, but having different amplitude and different initial phase angle. Right? Now, composition of these two SHM. Now, composition of these two SHM is according to principle of superposition of waves. Now, what is that? So, I can say that according to principle of superposition of waves. What this principle of superposition of waves says that is resultant displacement of SHM is nothing but vector sum of displacement produced by each wave individually. Now first wave has a displacement x1, second wave has a displacement x2. So resultant displacement x is equal to x1 plus. This is called as the principle of superposition of So according to principle of superposition of wave, I can write down x is equal to x1 plus. Now I can just put the value. So now what is the principle of superposition of waves? The resultant displacement of composition of SHM is equal to vector sum of displacement produced by each wave independently. Clear? So that equation I have written. Now in this equation I can put the value x1. What is x1? A1 sine of omega t plus phi. This is your x1 value. Plus, now I can put x2. What is x2? This is your x2. So x2 is what? A2 sine omega t plus phi. Clear? I have added it. Now, what is the next step? A1 in bracket. Now this sine omega t plus phi 1, I will do the expansion of that. Using which rule? We have this rule, that is sine a plus b in trigonometry can be written as sine a cos b plus cos a sine b. So this is my trigonometry rule. Now this trigonometry rule I can follow for the equation. Now if I compare that sine a plus b with sine omega t plus phi 1, so a value is omega t and b value is phi 1. So using that trigonometric equation, I can write down here sine omega t here cos phi 1 plus cos omega t sine phi 1. This is the expansion of your this one. Now I can go for the next one. Next term is what? Plus a2 in bracket. Now next term is what? Sine omega t plus phi 2. In this equation, omega t is nothing but a and phi 2 is nothing but b. So I can use same formula again. So what is that? So according to that formula I write now sine omega t plus cos phi 2 plus cos omega t sine phi 2. Clear? Now, here, this is the first term and third term. In the first term, there is a sine omega t, and in third term also there is a sine omega t. Means from first and third term, I can take sine omega t common. In the same way, this is the second term, and here is the fourth term. So in second term, there is a cos omega t, and in the fourth term also there is a cos omega t. Means from second and fourth, I can take common factor as a cos omega t. And now I can rewrite that equation. So I write down here x is equal to. Here I say that if I take common sine omega t. So sine omega t I have taken common. So what is remaining? This a1 goes inside. So a1 cos alpha 1 and here it becomes plus a2 cos alpha 2. So I write down that a1 cos alpha 1 plus a2 cos alpha 2. Means first and third term get finished. Now what is remaining? Second and fourth. So from second and fourth, I can say plus cos omega t. So now this cos omega t is taken common. Now inside the term is what? Sine phi 1 and this a1 will be for multiplication. So what it becomes? a1 sine phi 1 plus a2 sine phi 2. Clear? Any doubt? Okay. Now here, this first term is a cos term and second term is nothing but the sine term. Now I can do the replacement. What replacement I will do? I will call that r sine delta. I can write for all sine terms. All sine terms are what? a1 sine phi 1 plus a2 sine phi 2. So for these two sine terms, I can write a one combined term as an r sine delta. Similarly, for cos term I can write down r cos delta is equal to a1 cos phi 1 plus a2 cos phi 2. Are you getting? Means now I can change this term. So instead of a1 cos phi 1 plus a2 cos phi 2, which term I am going to put? R cos delta. And a1 sin phi 1 plus a2 sin phi 2. Instead of that, what I am going to put? R sin delta. Clear? So this equation I can call equation number 1. This equation I can call equation number 2. So from equation 1 and 2, from 1 and 2, my main equation of displacement x can be become as sin omega t in bracket r cos delta plus cos omega t in bracket r sin delta. Clear? In that r term is common. So what I get? X is equal to r in bracket sin omega t cos delta plus cos omega t sin delta. Now see here, omega t delta, omega t delta. Omega t is what? A. Delta is what? D. So what is that? Sin A cos B, cos A sin B. Instead of this term, I can write trigonometric equation R sin of omega t plus delta. So this is my resultant displacement equation when two SHMs will get compiled. So this is the equation of displacement of composition of two SHM. In that x is the resultant displacement, r is the resultant amplitude, and delta is nothing but the resultant initial phase. Got it? I'll again repeat. X means resultant displacement of composition of two SHM. R is the resultant amplitude of composition of two SHM. And delta is nothing but the resultant initial phase angle for the composition of phase. So my next job is what? I want to find out value of R and I want to find out value of delta. Clear? So now I will go for that. Now, if you see carefully in the equation, you have equation number 1 and equation number 2. Equation number 1, left hand side is R sin delta. Equation 2, left hand side is R cos delta. If I square this, what it becomes? R square sin square delta. This term will become R square cos square delta. In both terms, R square is there, so I'll take common R square. So what is remaining? You can add, after squaring, you can add these two equations. What will become? R square in bracket sin square delta plus cos square delta. And you have an identity. Sin square delta plus cos square delta is equal to 1. Means I will get value of R square. And if I take square root, I will get the value of R. Clear? So what I will do? Squaring and adding equation 1 and 2. So I will square and add equation 1 and 2. So if I square and add equation 1 and 2, so what I get it here? R square sin square delta plus R square cos square delta is equal to, now what is that? A1 sin phi 1 plus A2 sin phi 2 square. Add A1 cos alpha 1 plus A2 cos alpha 2. Here what is happening? R square in bracket sin square delta plus cos square is equal to, here squaring terms, what I am getting? A1 square sin square phi 1 plus A2 square sin square phi 2 plus 2 A1 A2 sine of phi 1 sine of phi 2. This is the expansion of first square term. Plus second term. Second term is what? A1 square cos square phi 1 plus A2 square cos square phi 2 plus 2 A1 A2 cos of phi 1 cos of phi 2. Now just concentrate here. First term and fourth term. Instead of this, I will take common what? A1 square. Here sin square delta plus cos square delta is what? R square. Here sin square phi 1 plus cos square phi 1 according to identity 1 plus I will switch over to this term A2 square cos square phi 2 A2 square sin square phi 2 A2 square cos square phi 2. From that A2 square common. So again this identity reduces to 1 and then I can take common twice A1 A2 is common. So what is remaining inside the bracket? Sine of phi 1 sine of phi 2 plus cos of phi 1 cos of phi 2. Clear? So now again I can use a trigonometry equation, and in that trigonometry equation, now what I am getting here, r square is equal to a1 square plus a2 square plus twice a1 a2 and this identity. What is that identity? Sin phi 1 sin phi 2 plus cos phi 1 cos phi 2 can be written as cos of phi 1 minus phi 2. Therefore, your r can be written as square root of a1 square plus a2 square plus twice a1 a2 cos of phi 1 minus phi 2. This is nothing but your resultant, right? And in your equation 1, if you divide that to equation, what I write? Tan delta. Tan delta is equal to nothing but a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. So this I am getting as a resultant initial phase angle, and this R I am getting as a resultant amplitude of composition of. Clear? So this is your complete 3-mark question, and whatever modification is there that we can see in the